Okay. dy over dx in terms of this. Let's just start it from the beginning. All right. Two ways you technically could do this. You could expand this form if you'd like to, right? We are deriving with respect to x, so if we go in to do this, we would drop the 2 in the front, leave what's inside, and then take the derivative of the inside. Derivative of the inside is 2y squared dy dx. Does that make sense, right? The residue of that. Here we have a 12x squared. Now we got to isolate him. So what we're doing here is divide by the 2. So you got 6x squared. Divide by this guy, 2y to the third plus 3. So that guy's gone. And then you could go and divide again by 2y squared. That makes sense? That's like multiplying by that is equal to dy over dx. Now let's go ahead and see if we can multiply this through. So that's 4y to the 5th plus 6y squared, right? 4y 5, 6y squared, okay? All over, and so that's the top, this is the bottom. They pulled out a 2, no, they pulled out, you could pull out the 2, so this would be a 3, this would be a 2, this would be a 3. I mess up on one of these, let's see, 6, 12, oh, that's what I messed up on here, right here. This should have dropped down to become a 6y here. Do you see that? That's what I messed up on here. So the division by this 6 over here should have been a 6y here, and the 6's could have canceled out. There we go. Okay. The 6's would have canceled out, meaning you had, let me rewrite this, x squared on the top, y 2y5 plus 3y squared. That's our answer. Do you see that? That was my fault here. I didn't drop the 3 in front. That's what I messed up on there. That makes sense? Okay, next one. It's funny how the first one their teacher gave you was the most extensive one. All right, next. 3x is equal to negative 5y to the third plus 2. Derive this, that's a 3. Derive this, that's going to give you a negative 15y squared, but don't forget your dy dx. That's the most important part. The 2 disappears. So 3 divided by negative 15y squared is equal to dy over dx. Cancel that out, so that's just a negative 5 on the bottom. So it's a 1 over negative 5y squared is equal to dy over dx. That one was, number 13 was the quickest one. That one makes sense? Number 14. This one's a little bit more extensive because the first thing I notice in this one, this guy right here, okay? That's going to take a little bit longer to derive. So 3 equal to x third plus 2x to the third, y to the third plus x. So this guy disappears. This turns into a 6x squared. This turns into a 1. This guy, we got to go and break him down a little bit. 6x squared, 3y squared dy dx. Okay? This is just break it down, find the derivatives underneath, if that makes sense. Multiply them out, so we'll go 2x to the third times the 3y squared dx, or dy dx, sorry. That's this side, plus 6x squared y to the third. That's this side. I'm going to still add our x. Make sure we add this as well. Okay. This here gives us 6x3y2 dy dx. We're going to solve for him in a bit. 6x squared y to the third plus x 2 to the third. Okay, so this all is equal to 0. So real quick, to move this over, this guy becomes negative, this guy becomes negative, this guy becomes negative. Does that make sense? So I'm going to rewrite the whole thing. This is equal to those three being negative. So 6x to the third y squared dy dx, that's just this. We move this over, and move this over. So negative 2x to the third minus 6x squared y to the third minus x. Okay. Then we're going to take what's in front here, divide the whole thing by 6x to the third y squared, and that's now equal to dy dx. Let's peek over here. Do any of our answers correlate completely to that? Wait, hold up. I messed up right here. Hold on. I didn't write these two down. So this is a 1 and this is a 6x squared. Right? Because I didn't rewrite those two guys. So 6x squared minus, hold on, 6x squared minus this minus that over that d. You see that? And I'm going to tell you here, even as a teacher, I make these little silly algebraic mistakes. I forgot to grab my derivatives. I went back to the original function by accident. That was my fault, right? But my derivatives are right here. Have this middle term as well. The main thing just to be careful with is you're always going to end up with this dy dx kind of smack dab in the middle of a lot of your functions, because as you find your derivative for it, it's actually in the middle of a product rule, middle of a chain rule, something like that. So you're going to have to move things over one by one and then divide whatever's multiplied by that dy dx onto the bottom, and that's how you get your answer. Does that make sense? Do you see the step-by-step of that?